All right, hello students. So here we are going to look at the exercise 1C selected questions and how you can actually present and answer these questions, right? So this is for your corrections. You should have already done this. Make sure you try and attempt the questions first before you compare your answer with mine, all right? So here's the first one that I asked you to try. It's question 13. The numbers 1080, 1188, and 1815, okay, are written in the product of your prime factors. So the prime factors are already given to you. And we are supposed to find the greatest whole number that will divide 1080, 1188, and 1815. So what number are we really looking for? Well, the greatest whole number, right? Greatest already give you the hint. Over here, we are actually looking for the HCF because the HCF will divide these three numbers, okay? So you need to understand that when we say divides, it doesn't mean that A divided by B, no, when we say divides, A can be divided by B is actually B divided by A. I know the language here is a bit confusing. It takes a little while to get used to it because of the way we have been so used to saying A divide B, right? But there's a difference between A divide B and A divide by B and A divisible by B and so on. So there are actually many different ways we can actually say division, which is why going forward as we get more exposure, we need to be quite aware of such things. And to minimize confusion, you will find that at more advanced level of mathematics, we actually try to avoid the word divide altogether, and we deal with fractions most of the time. But for now, we just getting our foundation right, so we need to get used to such lingo, such jargons, and such technical words. Okay, so looking for the HCF, what are we doing over here? Right, so let me change my pen color. Let's use blue. Okay, so finding HCF, let's list them down. 1080 equals to 2 to the power 3 times 3 to the power 3 times 5. Right, let me zoom in a little bit more. Can I zoom in? Yes, I can zoom in. It looks clearer. Right, so then we have 1188 is equals to 2 to the power 2 times 3 to the power 3 times 11. And then we have 1815, which is 3 times 5 times 11 squared. So we are looking for the HCF here. Well, let's look at the first prime factor, which is 2. Well, 1815 doesn't have a prime factor of 2. So we are going to ignore that, right? Now, 3, we have prime factor 3 in all three numbers right here. So what we're going to do, right, the HCF will include 3. And among the 3 of them, the common factor among all these 3 will be 3 to the power 1. So we have that. 5 don't have, 11 also don't have, right? Because when we say common among these 3, it must be all 3. Therefore, the HCF is 3. Therefore, the greatest whole number is 3, right? Good habit, just write down the statement. Okay, so let's move on to the next one. Question 15, right? So now the number 1120, 1276, and 1450, the prime factorized form is given. This time round, they want you to find the smallest non-zero whole number that is divisible. So notice the word, right? So in example 13, question 13, it says whole number that will divide. So we look for the HCF. In this case, they say find the whole number that is divisible by. So in this case, we will actually find the LCM because the LCM will be divisible by all these 3 numbers. So, well, unfortunately, if you are not very good with languages, you may struggle a little bit here, but not everyone can learn this. So get used to all these technical words. So we'll just list them down again, the numbers. We have 1120 is 2 to the power 5 times 5 times 7. We have 1276, which is equal to 2 to the power 2 times 11 times 29. Then we have 1450 is 2 times 5 to the power 2 times 29. So therefore, the LCM, well, LCM, we will take all the multiples of each prime factors, right? So for 2, prime factor 2, the common multiple will be 2 to the power 5. Then we have 5 to the power 2, right? Okay, so let me just quickly dot it with highlighter so you see what we are doing. So that's the 2. For 5 is over here. Next one will be 7. So we will do times 7. And then the next one we'll look at 11. so times 11. And then we have 29, right? So times 29. Well, at this point of time, we will need our calculators. So give me a moment. Let me pull out my calculator. Right. So my calculator, we have 2 to the power 5 times 5 to the power 2 times 7 times 11 times 29. Well, that will give us 86,400, right? That's the LCM. Okay, so I say therefore the smallest number is 1786400. Right? Good habit. Write down the statement. Okay, moving on. Next one, question 18. The highest common factor of two numbers is 175. The lowest common multiple of these two is 12600. Both numbers are greater than their highest common factor. Find the two numbers. So, well, the first thing we're going to do is we're going to list them down, right? So 175. List out the prime factorized form. 175, let me see, is, okay, where's my calculator? Is 5 to the power 2 times 7, right? 12600 is going to be equals to, give me a moment, let me work it out. 2, so 2 to the power 3 times 3 to the power 2 times 5 to the power 2 times 7, right? So you can actually work this out using your calculator. So let me just double check. 8 times 9 times 25 times 7. Yep, that's about right. So this is actually the HCF and the LCM respectively, right? So what happened now? What happened is these two numbers that I want to find, right? Let's call them A and B for now, right? So we look at each prime factor. So we have 2 to the power 3. There's no factor 2 in 175. So 2 to the power 3 must belong to one of them. So I just put it in either one. Okay. Then we look at 3 to the power 2. Well, 3 to the power 2, we need 3 to the power 2 somewhere, right? So we can put 3 to the power 2 here. Okay. Now 5 to the power 2 is common, as well as 7, right? So both of them will have 5 to the power 2, and both of these numbers will have 7. So we just allocate them accordingly, and then, well, let's work it out with our calculator, right? So 8 times 25 times 7, that will give us 1400 over here, and on this side, 7 times 25 times 9 give us 1575. Now, let's answer the question properly. The question says find the two numbers, so we say therefore the two numbers are 1400 and 1575. There we go, right? Okay, moving on. Next one. Question 20, right? So here we have Su Fen needs to pack 171 pens, 63 pencil, and 27 erasers equally into identical gift bags, right? So we are supposed to find the largest number of gift bags. In this case, we are actually looking for the HCF, right? So as usual, let's list down the numbers in prime factorization form. So 171, right? Let's work it out. We'll work this one out. Is 3 to the power 2 times 19, right? 63 is 3 to the power 2 times 7, and 27 is 3 to the power 3. Therefore, the HCF is actually equals to 3 to the power of 2, which is equal to 9. Now, please write down the statement, right? So, largest number of gift bags is 9, right? Part 2, the number of each item in the bag. So, we just go number of pen is equals to 171 divided by 9, which gives us 19, right? And then we have number of pencil is 63 divided by 9, which gives us 7. And number of eraser is 27 divided by 9, which is 3. Okay, and that will be fine. Okay, so we have that. Right, moving on. All right, so let's continue with the next question. So here we have a situation where sweets are sold in packs of 120 while mini chocolate bars are sold in packs of 18. Right, so Siti bought the same number of sweets as mini bar. Find the least number of packs of sweets she could have bought. So when she buy, definitely she cannot buy less than a pack. So what we are looking for is a larger number of sweets, right, or chocolate bars. So in this case, we are looking at LCM. So the same procedure, the first thing we're going to do is do prime factorization. After that, we look for the LCM. So let's go. 120. Oops, let me change my Apple Pencil because this one sometimes is quite wonky. Right, not text box, pencil, blue color. All right, so 120, this will be equals to 2 to the power of, let me see, where's my calculator? To the power 3, yes, that's what my calculator says, times 3 times 5, and then 18 is 2 times 3 to the power 2. So from here, the LCM is going to be 2 to the power 3 times 3 to the power 2 times 5. So that will be 8 times 9 times 5, 360. That means she bought 360 sweets, but the question asks for the number of packets, right? So number of packets, right? I will need to divide by 120 because 120 per packs. So least number of packs, my Apple Pencil, come on. Least number of packs is equals to 360 divided by 120 sweets per pack, 3 packets, right? 3 packs. Here we go. Okay, moving on, next one. Question 26. The number 528 and 540 written as product of their prime factors are given, right? So they want us to find the smallest non-zero whole number for which 528H is a multiple of 540. So as mentioned in class, this is the type of question where we're looking at the LCM. Okay, so part 1, right, LCM is equals to, so let's compare 2 to the power 4 versus 2 to the power 2, so it's 2 to the power 4. Then we have 3 to the power 3 times 5 times 11. So using our calculator, let's see what we get. 2 to the power 4 is 16 times 27 times 5 times 11. That gives us 23760. Right? You may want to work it out, or if you leave it in its prime factorized form, it works as well, right? So we are supposed, so that means that 528H is equals to 23760. So H is 23760. Come on, my pencil is not working very well. Over 528. So divide by 528. That gives us H equals to 45. Now, the next one, find the smallest whole number k for which 528 over k is a factor of 540. So Let's take a look. So what we want now is we want to find the HCF, right? So the HCF this time around, okay, is going to be 2 to the power 2 times 3, right? So that works out to be 12, right? So what happened? 528 over k equals to 12, right? So k over 528 equals to 1 over 12, right? So from here, k equals to 528 over 12. K equals to, let's pull out the calculator, 528 divided by 12, 44, right? So we got our H and K. Moving on. Right, this question, a class has between 30 and 40 students. Each boy in the class is to bring 15 chocolate bars for the class. The chocolate bars are shared among the 20 girls and their form teacher, right? There are no leftovers. So how many students are there in the class? Okay, so we know that's between 30 to 40. Now, what happened is the number of chocolates, right, have to be a multiple of 15 because each boy buy 15. And then it's shared equally among 20 students and one form teacher, so shared among 21. So what we're looking for over here is actually the LCM of 15 and 21, right? The LCM of 15 and 21, that will give us the chocolate bars, right? Number of chocolate bars. So from there, we can work out how many boys there are, right? And then after that, we will know the number of students. Okay, so let's go. So we have 15 is actually 3 times 5, right? 21 is 3 times 7, right? So the LCM is going to be 3 times 5 times 7. Let's go 3 times 5 times 7. That will give us 105. So what happened is the number of chocolate bars, right, will be a multiple of 105, right? So the thing is, can it be 105? If it's 105, it means that there is only 7 boys, right? If it's 105, because 105 divides by the 15 chocolates, so that gives us 7 boys. Now 7 boys, 20 girls, that class has only 27 people. No, that's not correct, right? Because you need to be in between. Okay, so number of chocolate bar has to be a multiple of 105. Therefore, let the number of chocolate bar be 2 times 105, which is equals to 210. That will work out fine, right? So let's see. From here, my Apple Pencil, number of boys will be equals to 210 over 15 chocolate bars. So let's press the calculator to confirm. 14 boys, right? So therefore, can we go to this part 1? Therefore, number of students is equals to 20 girls plus 14 boys, which is 34. So finally, how many chocolate bars does their form teacher receive? So basically, we are looking for how many chocolate bars each person receive. So part 2, number of chocolate bars received is equals to, right, 210 chocolate bars divided by 21. Because divide by 21, 20 girls and 1 teachers. So each person will get actually 10 chocolate bars. Okay, so that's the suggested solutions for the assignment I asked you to try. I hope you have been successful. Have a nice day.